everyone, we're going to find the area of the region enclosed by one loop of the curve. R equals 2 cosine of theta minus secant of theta. This is a stroke void, and it looks like this. I went ahead and graphed it, but let me show you how I did this. So basically what you do is we want to see where it passes through the pole. So you're going to let R equals 0, and you're going to get 2 cosine of theta minus 1 divided by cosine of theta equals 0. All right, so simplifying all this, this is just going to be 2 cosine squared of theta minus 1 equals 0. Because you get the common denominator, so we're going to have to square that. And then when you cross multiply, the denominator goes away. So basically we have cosine squared of theta equals 1/2. Therefore cosine of theta equals plus or minus 1 divided by square root of 2. So basically our angle is going to be pi divided by 4, or 3 pi divided by 4. For theta belongs to 0 to pi. And this is our angle cannot equal pi divided by 2. And that's because you can't divide by 0 here. So our angle cannot be pi divided by 2. All right, since we have that, we are going to go from 0 to pi divided by 4. And we're going to multiply it by 2 because this is your pole. And if I go 0 to pi divided by 4, I'm going to get this area. So if I multiply it by 2, it will also include this area here. Okay, so let's do that. Our area is going to equal, and you're going to multiply this by 2 to get both sides of the upper and lower part of the curve. And we're going from 0 to pi divided by 4 for our limits. So using your formula here, this is going to be 1/2 times 2 cosine of theta minus secant of theta squared d theta. All right, let's expand all this. This is going to be equal to the 1/2 times 2 is just going to be 1. So now that goes away. We have 0 to pi divided by 4. And let's expand this perfect squared trinomial. That's going to be 4 cosine squared of theta minus 4 plus secant squared of theta d theta. All right, so for this piece, what I'm going to do is do identity for this piece. So I'm going to get from 0 to pi divided by 4. And I'm going to write this as 4 times, and the identity I'm going to use is 1/2 times 1 plus cosine of 2 theta. It just makes it easier to integrate, and then copy everything else down. All right, d theta. All right, now that you have that, let's simplify what we have. We have the integral from 0 to pi divided by 4. This is going to be, when you multiply these, this is going to be 2 minus 4. So that's going to give you -2 plus, and then when you multiply this 2 times cosine of 2 theta, you're going to get 2 cosine of 2 theta. Then just copy down your secant squared of theta, d theta. Now at this point we can integrate, so let's do that and find our area. So when you integrate, you're going to get -2 theta plus sine of 2 theta plus tan of theta. I just took the antiderivative of everything. Now evaluating this, you're going to get -2 times pi divided by 4 plus sine of 2 times pi divided by 4 plus tan of pi divided by 4 minus everything else is just going to be, when you do the lower limit, it's just going to be 0. So now we just have to clean this up. This is going to be negative pi divided by 2. This is just going to be sine of pi divided by 2, which is 1. Tan of pi divided by 4 is 1. So this is going to be 2 minus pi divided by 2, and that is your area of the inner loop. Thank you. Have a nice day. Bye-bye.